Okay, so we'll look at what the instructions are. Tabulate and list the latitudes and departures for the figures shown below. Show to 3 decimal places. Calculate the bearings and label on the map. Angles are already balanced. Find the error and the precision. Okay. So some of the first things we're going to have to do is figure out the bearings. Okay. So that way we can figure out our latitudes. So how are we going to figure out those bearings? Well, I'm given a bearing here, right? And I have all the interior angles of this figure. So I should be able to figure out my bearing of each of these lines based off this bearing with these angles. Okay? So we have a southeast bearing here. We have to turn that into a northwest in order to figure out this line. Because this angle is turned from the northwest that way, right? So can somebody tell me what the bearing is of this line here? Of course, I conveniently neglected to bring my calculator again.
It's going to be like something.
14 degrees. When you get 47. 51. North, 75 degrees, 13 minutes, 25 seconds. East.
How do we know that's a northeast?
Because there's a compass by your finger. Oh.
Well, that's one of the questions you get, you know, because you probably turn this into an azimuth, right? Turn it into a northwest azimuth, and then you just added and then subtracted 350 or 360.
Oh, maybe I did it wrong. I did 90 degrees minus 14 degrees.
That works too.
Okay.
So, all right, so that's our bearing there. So let's figure out our bearing here now then. So we're going to have to turn this into a southwest bearing in order to figure out this one. Okay.
Yeah.
So it's south 75, 13, 25 west now. Which is also the same as south 55 degrees, 13 minutes, 25 seconds. Or not south, sorry, azimuth of 255, 13, 25. I just take 75, 13, 25 plus 180. So I get north 14 degrees, 04 minutes, 00 seconds, east. And how about the last one? You turn this to a southwest bearing again and add 88 degrees, 00 minutes, 05 seconds. But then subtract 360 to get the bearing of it.
Oh yeah, that should be right. That should be it.
Anybody got a bearing for me yet?
I do, but I don't know if it's right. 77 degrees.
Okay. What is it? 77 degrees.
North 77 degrees, 55 minutes, 55 seconds, west.
That is indeed what it is. Alright. So we got our bearings going around. Okay, now we're going to figure out our latitudes and departures. Okay, so how do we find our latitudes and departures?
It's cosine and stuff.
Yep, so the change in latitude is equal to the cosine of the bearing times the distance. So change in latitude is equal to cosine of the bearing times the distance. Change in departure is equal to the sine of the bearing times the distance. Okay, so let's figure out what the change in latitude then is from 1 to 2. From 1 to 2. What's the change in latitude there? So it's going to be the cosine of 14 degrees, 47 minutes, 51 seconds, times the distance of 543.33.
543.
543.33.
I got 525.31.
And I want it to 3 decimals.
0.
5.310. Okay. What direction are we heading with that?
Southeast.
So would my latitude be positive or negative?
Negative.
Going from there to there. It's negative. Okay? I'm going to show it as a negative. How about my departure for that same line?
Oh, that'd be positive.
It's a positive.
138.768.
So it's 138.768. And it's positive because we're heading in the positive direction in the departure side. Okay? So let's figure out the change in latitude and departure from 2 to 3. I can sketch this on there so you guys can basically trying to figure out those. So this is the latitude, this is the departure.
6, 7. What's this?
Oh, sorry. So the bearing is 77, 13, 25, and the distance is 367.22.
I got 93.658 positive.
For the latitude?
Yep.
93.658. And that's positive because we're going in the positive direction, right? North direction. Yeah, with the easting. Or the departure.
355.076 positive.
355.076, and that is indeed positive. Okay, so let's find the next one. Departure, latitude.
309.483. Right?
309. Sorry. Point what? 483, and it's a positive, right? We're going in the positive direction again. So let's figure out the departure now.
77.545.
77.545. And that's positive also?
Yep.
Okay. Okay, yeah, we went positive for both because we're heading into the northeast direction. How about the last one now, from 4 to 1? Okay, from 4 to 1. 122.120. Is it a positive or negative? Right, we're heading in the north. It's positive. How about the departure?
Negative 571.191.
Negative 571.191. All right. So to figure out our error, we basically sum the latitudes, place it here, and then sum the departures and place it there. Okay, so what is our error by summing the latitudes? Whenever someone has the sum of the latitudes, fire away.
Negative 0.049.
Negative 0.049. Okay. How about the departures?
0.198.
0.198. That's positive, right? Okay. Now we found our error, we can calculate our precision. How do you think we're going to calculate our precision? We need to know one more thing, I think, before we can calculate our precision.
Total length of all sides.
Well, yeah, we're going to need the total length of all sides. That's one thing we're going to need. But so if I write out the relative precision, if I write this equation out, relative precision is the traverse length over the linear misclosure. Okay, this is different from your book. Your book states it as relative precision is linear misclosure over the traverse length. But then we'd have to take the inverse of that to get it to be the actual precision. So this is just the quick way to actually displays the actual precision. You just have to make sure you remember it's one in whatever you get from this. So
Is linear misclosure the difference of those?
no. So that was a good question though. Is linear misclosure, because we don't know how to calculate that yet, right? I haven't given you that yet. So is linear misclosure just the difference between the latitude and the departure? No. And I'll show you why. So basically, when we came around, the end of our traverse, when it came together here, is not closing. That's what this is telling me, that our traverse is not closing. So if I look at this and put it in a microscope, and I look, and my two ends are like that apart, okay? So this is just a zoomed in of that. All right? So if I look, my change in latitude, so this is the change in departure, and this is the latitude. So the departure is 0.198, and my latitude is negative 0.049. Okay? That's the difference between them. So how do I find the actual linear misclosure? I'm looking for the hypotenuse right here. Okay? So this is what we're looking for. That's our linear misclosure. So how do we find that?
0.049 squared plus 0.198 squared.
Pythagorean theorem.
Square root.
So I'll write it out for you. So the linear misclosure equals the square root of the change in departure squared plus the change in latitude squared. Now, this change in latitude and departure is the linear error change in departure and the linear error change in latitude that we're going to put on there, okay? Sorry, I didn't have that down. So this is the change this is the linear error departure. That's the linear error in the latitude. And that would give us, what is our linear misclosure then?
0.204.
So it is 0.204. That's our linear misclosure. Alright, so then how do we find out the traverse length?
Add the two together, or add the four sides.
Yep, add the four sides together. Okay? Yep, the four sides together. Add those together. So let's get our traverse length there. What's the traverse length?
I can't see all the sides.
Sorry.
$1,813.700.
1,813.70.
Yeah, it's just 7, so I'm guessing.
Yeah, 70.
Is that what you got? Hold on.
I kind of missed that.
Might be wrong.
Okay. All right, so let's figure out our relative precision then, because that's what we're looking for really, is the precision. So if we take that and we put the 1813.70 and divide it by the 0.204, what are we getting for our relative precision then? What is it? 8890 point what? 6. I want it to 3 places. 686. Okay? So our precision is 1 in 8,890.686. Does that meet Wisconsin state statute or standards for precision on a survey?
Yes.
Yes, so technically we wouldn't have to adjust it. But because we're surveyors, we like to make things perfect, so we adjust. We're not going to adjust it today. We'll get into that next week on how adjustments work for traverse adjustments. But I just wanted to make sure you guys got this portion of it figured out. So, any questions on this particular thing? You guys have sort of done a little bit of this already, so
Somewhat.
yeah.
Minus the latitude departure.
Yeah. So, doesn't this look awfully familiar though to the double meridian distance
Yeah.
area problem in Civil Public Works?
That's what I was-
Yeah. So it looks an awful lot like that. So, all right.